On this session of bipolar junction transistor networks, we will cover common base configuration, DC analysis of common base configuration. Now with common base, for this configuration, as you can see, our base terminal is connected to our common terminal, or our reference, in this case, our ground. And again, this will become clearer why we refer to it as common base. The other circuits, if you were able to watch the videos already, we have common emitter and common collector. All of this should be cleared when we reach the AC analysis. But for common base configuration, it's pretty obvious that our base terminal is connected to our ground. And for input voltage later during AC analysis, this is where the input voltage or source of our AC input will enter our network. And as you can see, we have here positive and negative on the other end. This is where you're going to extract naman the output signal. Okay, so output amplified signal. So as you can see, we have our base as common to both the input and output terminal. So one way of saying it's common base, aside from the base is directly connected to your common ground. And for this configuration, we have R sub E. Okay, we have R sub E and R sub C. You can also notice that we have two supply voltage. We have VCC, okay, and the other one is V. For the base emitter junction, the same with emitter follower, we have a negative supply voltage here to force our base emitter junction to be forward biased. Whereas for VCC, this will force our base collector junction to be in reverse bias condition. Okay, so putting this configuration again in the active region. What is active region? Kindly refer to the previous videos, probably the introduction to transistor operations. So kindly use our website to navigate or to select the videos. So to start our analysis, we need to find a loop wherein we can have a closed circuit. So in our case, it's easier to use this loop, okay, because we know the value of VBE. If we're going to use this loop, we do not know the value of BC, this part. So we will have two unknowns, RC, not RC, IC, I sub C, and VBC. So we will use the other, loop, the VBE loop. We refer to it as VBE junction loop. Okay. So following this loop, let me adjust our screen so to give more space to our equations. Following that loop, so you can see that we will start with 0 minus. Okay, so zero minus the voltage on this junction. So that's VBE. And minus the voltage across RE. So that's VRE. So again, VRE, voltage across RE, is not necessarily the same with VE, especially in this case. So we will have also VEE. So instead of minus, we will have plus, because the polarity of our battery is the same with our chosen path. or loop. So meaning we'll use here V plus VE. Plus VE, and then we were able to return to our ground, so this is equivalent to 0. Now we can look for the ohms equivalent of this voltage. So as you can see, this is the voltage found on your resistor. So we can use Ohm's law on this component. So we'll have negative VE minus the current flowing through it is I sub E. So remember, this is emitter terminal. So current here is I sub E, or emitter terminal. So that will also flow through your I sub E. And the current flowing through this part naman of our circuit, wait, this is forward biased. Yeah. So yeah. So meaning for our current flow, we will also have I sub C. Okay, so I sub C going this way. Same thing with IB naman. So for IB, we also have a current flow. So where do you think current will flow with IB? Is it going downwards or upwards? So as you can see, I sub E is equal to IC plus IB. So meaning IB natin is going that way. Okay. So that's not sure ano po, current flow for common base. And then let's start our analysis for IE for V sub RE. So that's IE times resistor R sub E plus VEE. So VEE, supply voltage VEE equivalent to 0. So meaning you can actually solve for IE, which is equivalent to IE is equivalent to VEE minus VBE divided by R sub RE. Yeah. So once you're able to solve for IE, you can solve also the other circuit currents. Let's say following this equation, I sub E is equal to beta plus 1 IB. So it follows that IB is equal to I sub E, or your emitter current, divided by beta plus 1. Once you're able to solve for I sub B, you can now calculate the value of collector current. So that's beta times I sub B. Okay, so that's all for the introduction of common base configuration. On our next video, we will have an example of putting these equations at work